Dear grade 12 learners, welcome to today's mathematics lesson. My name is Chapang Mapotani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12, in today's lesson, we are looking at our second part of our paper 2 revision. And for this lesson, we are going to focus on Euclidean geometry and measurement, and we are also looking at analytical geometry. Now, by the end of this lesson, you must be able to know and identify the structure of paper 2, and we are focusing on the topic of analytical geometry, and we are also going to focus on Euclidean geometry and measurement. Now, grade 12, these are the topics that are in our paper 2, and we are now saying for this lesson, we are going to focus on analytical geometry and Euclidean geometry and measurements. Now, remember, again, when we are working with paper 2, be able to navigate through our formula sheet, as we can see right there. More especially now that we are going to start by focusing on analytical geometry, be familiar with the formula sheet, know which formulas are in our formula sheet so that we are able to apply these formulas. Now, grade 12, we have question 3, and this question 3 comes from our 2020 paper 2. And for this question, grade 12, you are given 10 minutes to complete this activity, and your 10 minutes start now. Welcome back, grade 12. Now, let us now focus our attention to the solutions of this activity. Without just looking at the statement, let us just analyze our diagram. What do we see in our diagram? In our diagram, we can see we have the WR being parallel to the y-axis. We are given STK, we are given an angle alpha, we are given a beta there. We can see if we're given alpha and beta, we can now think of those angles that we need to find the solutions to. So those are the angles of inclinations that we might be required to calculate. Then we can now see we have a point P which is intersecting on the y-axis, and we have W right there. Remember, we are not going to make any assumption. We are going to analyze our diagram based on what is given. Now we are told that triangle TSK, so triangle TSK, it is drawn. We are given the equation of ST. So the equation of straight line ST, it is y, it's equals to 1 over 2x plus 6. And the ST cuts x-axis at M. Okay, they're telling us that ST cuts x-axis at M. That is to say, if we are looking for the coordinates of M, we know that we're going to say x-intercept y is equals to 0, because that ST, it is cutting at M. Then we are told that W, which is negative 4 and 4, lies on ST, and R lies on SK, such that WR is parallel to the y-axis. We could see that by the markings right there, and our statement also supports what we have seen or have identified from our diagram. And WK cuts the x-axis at B, and the y-axis at P, which is 0 and negative 4. So the P, it is the y-intercept, and KS is produced and cuts the x-axis at N, then TSK is theta. Now let's look at 3.1. 3.1 reads as follows. Calculate the gradient of WP. So the gradient of W and P. How are we going to find that gradient? We are going to copy down the gradient formula, MWP. Remember, it is y2 over y minus y1 all over x2 minus x1. Remember, this it is found in our formula sheet. Right. Then we can now substitute in the coordinates of W and our coordinates of P. Then the coordinates of W, we're going to start with W. So it's 4. So it's 4 minus the y coordinate of P is negative 4. all over the x coordinate of W is -4 minus the y coordinate of P is 0. Then our MWP equals to 8 over -4. Then this is a 8 divided by -4, it becomes -2. That is our WP. 3.2, show that WP it is perpendicular to ST. Remember, if WP is perpendicular to ST, how do we show that two lines are perpendicular? It means now the gradient MWP, when I multiply it with the gradient for ST, I must get the answer as -1. Now, let us remember that the MST, it is already given. Our ST, we're given the equation then the gradient, because this is given as a straight line, it is y, it's equals to mx plus c, then y is equals to 1 over 2x plus 6. Then our m, it is 1 over 2. So MST is given, and MWP, we have found it to be -2. Now, let us multiply them together. So when I multiply the gradient of WP times ST, WP, it is -2. Our ST is 1 over 2. Then our answer got -1. Then we can now conclude that, therefore, WP, it is perpendicular to ST. Because when I multiply their gradient, I got -1. If the equation SK is given as 5y plus 2x plus 16 is equals to 0, calculate the coordinates of x. Let us go and look at what is x. As it is found, it is the intersection between ST and SK. Then how are we going to find the coordinates of x? So if it is the point of intersection, we are going to use the simultaneous equation to find that point. As remember, when you use simultaneous equation in paper 1, we are finding where the two lines they intersect. So we are going to equate the equation of ST to the equation of SK. But before we can do that, we are going to take the equation of SK and we are going to simplify it so that it is now written in a standard form. To get it in a standard form, it must be written in a form y is equals to mx plus c. Then we now find our SK in a standard form and ST in a standard form. To find S, we are going to say equate the two. We are going to use the simultaneous. So this is SK is equated to ST. So that is how we are going to apply simultaneous equation. Or we can use the substitute method. I can use equate because both of them is y equals to. Thereafter, what do I do here? I will now multiply by my LCD. My LCD for this one is going to be 10. It's 2 and 5, so it's going to be 10. So I multiply by 10 throughout. Then I get -4x minus 120 is equals to 5x plus 60. Using our LCD as 10 in this case, then we can drop those denominators there. Then we get now, we can now work with our like terms. So x, -4x minus 5x, what we're going to get? We're going to get -9x. It's equals to 60 minus or plus 120, it becomes 180. I can divide by -1 both sides. I get 9x equals to -180. Then I can divide by 9 both sides. Then I get my x, it's equals to -20. After I get my x equals to -20, then the x coordinate of s, it's -20. To find the corresponding y coordinate, I will substitute x equals to -20 in any of the two equations. So I can substitute it in my SK, and I can say in the space of x, I substitute in -20. Then my y, corresponding y value is -4. Then therefore s is -20 and -4. Now, grade 12, we have from 3.4 now to 3.6. And for these two questions, you are given another 10 minutes to complete these 3 questions. And your 10 minutes starts now. my grade 12. Now, let us look at 3.4, let us look at 3.5 and 3.6. 3.4 is as follows. Calculate the length of WR. How would you find the length of WR in this case? The first thing that we're supposed to do now, it is to find the coordinates of R. How would you find the coordinates of R? We are already told that the two lines are parallel. So if they are parallel, that means the x value, which is this -4, it is going to be the same for R. So R already we have -4 in this case. So we have two options. We can either subtract the two to find the length, subtract the top one or the bottom one, or find the coordinates of R, which is what I was discussing already, but we're going to look at that after. How can we do that with option one? To find the length in between two equations, we can take the top line, subtract with the bottom one, so it is ST minus SK. Then I get my answer is 9 over 10x. So when I work this and that, I get 9 over 10x plus 18 when I simplify. Thereafter, what do I get here? I will get, say, substitute x equals to -4. Why -4? Because this is the x coordinate of R. Remember, our R we said is -4 because the two lines are parallel to each other. So R already, x value is -4. Let's just go straight there. Then to find the corresponding value is going to say substitute x equals to -4. Then we find our answer to be 14,4 units. That's how we can find the length of WR. On the second option, when you look at second option, on the second option, remember, we said you find the coordinates of R and use the distance formula. Now remember, our R coordinate, we have already established our x coordinate of R is 4 because the WR is now parallel to the y axis. That means this x value, it is the same throughout that line. Then, as this will give us 90 there. Then we can find that our y or corresponding y value of R it's now -52/5. So the coordinates of R is -4 and -52/5. Thereafter, I know that my W already, it was given as -4 and 4. Then what do I do from here? I can use my distance formula, which is now the WR. And remember the distance formula, it is given to us in a formula sheet, and it is as follows. D is equals to, so it's going to be D is equals to x2 minus x1, or you can start with the y squared plus y2 minus y1. That is how we use the distance formula. Right, you can punch everything in a calculator, and my distance WR equals to 14,4 units. Remember, we can subtract the top equation and the bottom equation, or we can use the distance formula. Let us look at 3.5. 3.5 reads as follows. Calculate the size of theta. Theta is found on our triangle right there. How are we going to find that theta? We are given SK. So we can find the beta first. As we are given SK, and I can find the beta, and after finding the beta, I can find that angle, and I can find the two angles right there. Right. So what am I going to do? Find the beta. Then beta is going to be, remember, tan beta, it's equals to MSK. Then beta, it's equals to the second function of tan SK, it was -2/5. Then we get it is -21/801. Then we know that we can't have a negative angle. We're going to add 180. Then our beta is 158,19. What can we do from here? We can now find the value of M and S. We can find this angle. Then we can do what? We can find the angles in the straight line. So angles in the straight line, they are supplementary. Then we can now find this value to be 21,8. Right. That is our value right there. Then again, our MST, it is equals to 1 over 2. So let's find what is the value of that angle right there. So how do we now find that value? We can see that is the value of inclination for ST. Then we can now find the value of WMV. It is equals to, so it's tan of WMV, it's equals to MST. Then WMV, it is the second function of ST, which is 1 over 2. Then WMV, it is 26,26. Then we notice that NMS and these two angles are equal. These are vertically opposite angles, right? Then ever since now we have found the two angles that are equal, then I can find my alpha or my theta to be an exterior angle of a triangle, which is now going to say our theta is equals to the angle of MNS, which is the 21,8, and the angle of 26,56. We can use that, or we can find all the sum of the interior angles of a triangle, find this angle and find that angle of the angle on a straight line. Then I can find that my theta is going to be 48,37 in this case. So that's how we found the angle theta. Now, we are told that in 3.6, let L be the point on a third quadrant. Okay, here's my third quadrant. Have a point L somewhere here, such that WSR, so it's WLR, it forms a parallelogram. Okay, so it must be a point where we are having a parallelogram, right? Calculate the area of SWRL. So they want the area of the whole parallelogram right there. How do we find the area of that parallelogram? We can find the area of the two triangles, because we can see we are creating the two triangles here, and we have another triangle right there. So what we can do is the following. We know the coordinates of S, it was -20 and -4. The coordinates of W, it is given. The coordinates of R, our R, it was -4 is to -52 over 2. Now, to find the area, we can find the length of SW first. Then we get our SW as our 8√5. So we substitute the values of S and the coordinates of W to find the distance of SW. Then we're going to find SR, because we are looking for the area of this triangle. So the area of the triangle that is in blue. Remember, we can find the area of the two triangles and add them together. So if I want the area, because we already have that angle, I need to use this side and that side. Then the SR, it is now the root 16√29 over 5. Then I found the two sides, then I will use that included angle to find the area of that. Then the area of SWRL, it is 2 times the area of SRW. Why is that the case? Because the diagonals bisect each other. When the diagonals bisect in this case, and the diagonals, they cut our parallelogram into two equal triangles. So if we have another diagonal here, they'll bisect each other, but that won't work for us with the diagonals bisecting each other. But we can work with the fact that this will now give us the two same triangles if this is a parallelogram. Then now let's find the area of SRW. It's equals to 1 over SW, which is the side, multiplied by SR, sine of the included angle, which is the sine theta. Then the area of SWR, it's equals to 2. Remember, we are repeating this triangle twice. It's going to be repeated twice. It's equal to 2 into 1 over 8. SW multiplied by SR sine of the Euclidean angle, which is sine theta. Then the area of SWR, it is 230.41 units squared. Now, grade 12, let us look at question 4. Our question 4 comes from our November 2023. And for this question, grade 12, you are given 10 minutes again to complete from question 4.1 to question 4.3. And your 10 minutes starts now. Welcome back, grade 12. Let us look at 4.1. Now, to look at 4.1, we are told that in the diagram, the circle with center O has the equation, okay? So you have a circle with center O, which is a small circle, then it is the equation of x squared plus y squared equals to 20. And that makes sense because it is centered around the origin. And G, which is T is to 0, it is the center of the larger circle, okay? And A is the common, our line A, where is A? I think it's DF. So our DF must be that common tangent that touch at D and F respectively, or a common angle or a common tangent, apologies them, a common tangent at D and F respectively, such that we have the coordinates of D as P and -2. Lies in the fourth quadrant, which is that D right there. Given that D into P, which is the coordinates of D is P and -2, lies on the smaller circle, show that P is equal to 4. Remember, on a smaller circle, we're given the equation of the smaller circle. So what we're going to do, we are going to substitute the coordinates of D on the equation for the smaller circle. That is where our D is found. So we're going to substitute D in the equation of the smaller circle. Then when we do that, we can see that our x is P. So when there is x, I have placed in P. So I have P squared plus our y is -2. Where there is y placed in -2, it's equals to 20. Then from here, I know that my P squared is equals to 20 minus 4. 2 squared is 4. Then P squared is equals to 16. Then our P, we're going to root both sides. When we root is plus or minus, our P, it is equals to plus or minus 4 in this case. Remember, we are now going to see that our P, as it is the x value, it cannot be negative, it's on the right hand side. Then therefore, our P will become 4. Because P, it is the x value on the positive x axis. Right. Let us now look at 4.2. 4.22 reads as follows. The coordinates of E, which is E is 6 and 2. Remember our D, it was 4 is to -2. Then we are told that E, it is 6 and 2, which is the midpoint of DF. Okay, they are telling me that E is the midpoint of DF, meaning I am going to utilize the midpoint formula to work around the coordinates of F. Then how would I work and find the coordinates of F? We know the coordinates of D and E. Remember, to find the coordinates of a midpoint, so the midpoint, which is E in this case, it's going to be x1 plus x2 all over 2 and y1 plus y2 all over 2. Remember, this gives me the x coordinate of E, and the second part will give me the y coordinate of E. Why? Because E, it is the midpoint. And remember, this formula is found in our formula sheet. Then what do we do from here? I will now take the first part and work around it. That is to say, we will now say x1 plus x2 all over 2 is equals to x coordinate of E. What is x1 and x2 in this case? We are now going to say our x1 it's going to be, it can be the x coordinate of D, and our x2 is going to be the one of F in this case. So that's how we're going to work it over 2. Then I substitute the x coordinate of D, which is 4. I substitute in the x coordinate of E, which is 6. Right. Thereafter, I can solve for xf. Then my xf is 8. The same procedure I'm going to follow for y. Remember, yd plus yf all over 2. It gives us the ye. This is the second part that we're working with, which is the y coordinate of the midpoint, which is e. So ye. Then when I work around that, what do I do? The y coordinate of D, it is now -2 plus y coordinate of F is what I'm looking for, all over 2. It's equals to the x coordinate of E, or the y coordinate of E, which is 2. Then I solve for the y coordinate of F, which is now 6 in this case. Then therefore, our F is 8 and 6. Right, 4.3, it says determine the equation of the common tangent df. So this is the common tangent df. We need to find the equation of the df in the form of y equals to mx plus c. How would you find the coordinates of df? We need to find, the first thing that we need to find, it is the gradient of df. Remember, we need to find the m from the standard form. Then the gradient of df, we are going to say, we can use dE. Remember, the MDE and MDF are the same because DEF are collinear points. Because they're collinear points, the gradient is the same. Thereafter, I find MDE, substitute DE, and coordinate of D and coordinate of E. Then I get my MDE is equals to 2 in this case. Then I will substitute my gradient into the coordinate form. Remember, the coordinate form is y minus y1 is equals to m into x minus x1. Thereafter, it's y minus y1 it's equals to our m, it is 2 into x minus x1. Then how do we further work around this problem? We are going to substitute a point on the same line, either D or E, even F we can substitute. Any of those will give me the same answer. So I'm going to say substitute a point on our line DF. So in this case, we can substitute D, which is 4 and -2. So in a space of y, I place in the -2, y1 them, then my x1 is going to be +4 in that case. Then I can now say y negative and negative will give us a positive. So we are going to have y plus 2 is equals to, then we're going to say 2 times x is 2x, then 2 times -4 is -8. Then I can simplify, I have found my y equals to 2x minus 10. Now, the 12 we have from 4.4 now until 4.6. And for these questions, grade 12, you are given another 10 minutes to complete this activity. So your 10 minutes start now. Welcome back, grade 12. Let us now look at 4.4. 4.4, it says, calculate the value of t and show all of the working out. How do we find t? T is the center of the large circle, is the x-coordinate of the center of the larger circle. Now, to find the coordinate t, what do we do? We need to find the equation of fg. How would you find the equation of fg? Remember, we already have the equation of df, and remember, now this is a tangent. Tangent is perpendicular to the radius. So we know that our m tangent multiplied by m right, I must get -1 because they are perpendicular to each other. So we know radius is perpendicular to a tangent. then that is to say we are going to use the tangent gradient, multiply with that to get gradient of FG. Just close a bit there. Now, so from DE, which is y equals to 2x minus 10, our MDE, it was found as 2. Thereafter, you must remember that MGF, which is our radius, multiplied by DE, which is our tangent, is equals to -1, where we say the radius is perpendicular to tangent, or tangent is perpendicular to our radius. Then we can substitute in the values. Remember, my GF is what? It is MGF multiplied by MDE, which is 2. It's equal to -1. I divide by 2. We divide by 2. Then MGF, it's -1 over 2. Right. From here, we can find we can find the equation of FG, or we can use the gradient of FG again to find the coordinate of T. Either way, we are going to find the correct answer. Then if I can use the gradient of GF, I will now say MGF is equals to -1 over 2. But MGF, how do we find MGF? To find our MGF, we're going to say is y2 minus y1 all over x2 minus x1. It's equals to -1 over 2. Right, I think this is the shorter way we can use, and we can also find the equation first, and that will also work for us. Right, then what do we do from here? Then the y coordinate, or y2, is going to be 0 minus the coordinate of f. Then it was, remember our f, it was 8:6. So it's y minus, so the y is what? Is 6 in this case. So it's going to be 0 minus 6, which is the y2 minus y1 all over the x value of g, which is t. So it's t minus our 8, which is our x value of f in that case. Then from here, we can cross multiply. We get -1 multiplied into -t minus 8. It's equals to 2 into -6. Then we can now find our t is equals to 20. So that's how we can find the value of, we can find our value in that case, which is the value of t. Determine the larger circle in the form of ax squared plus by squared plus cx plus dy plus e. So we're looking for the equation of the larger circle. Remember, our g, it was 20:0. Our f, it was 8:6. How do we find the equation of a circle? Remember, the standard form for the equation of a circle, it is into x minus a all squared plus y minus b all squared is equals to r squared. Then what do we do from here? We're going to substitute the center, which is g. Then remember, our coordinate of a center, it is a:b in this case. Then our a is 20, and our b is going to be 0. When I substitute the two, our a is 20, our b is 0, then I get that to be x minus 20 all squared plus y minus 0 all squared equals to r squared. Now, to find the value of r in this case, we are going to substitute a point on the larger circle, which is our f. Then when we substitute f in this case, we are going to get our r squared, which is 180. Then from here, we know that x minus 20 squared is equals to y squared, it's equals to 108, which is r squared. Remember, y minus 0 is just y squared. Then I can distribute the first part and simplify, and we can get our equation to be x squared plus y squared minus 40x plus 220. So distribute the two and now find and work around that value there. Right. 4.6, it says, the smaller circle must be translated k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. How do we find the possible values of k? There are two ways that these two circles can touch internally. the first thing that can happen is I need to translate the smaller circle, and if the other circle is there, right? And this point we know that G, it was 20 is to 0. So this point is going to be that 20 plus the radius of a larger circle. So this is going to be 20 plus the radius of a larger circle is 6 root 5. And this point, it is going to be what? It's going to be 20 minus the radius of the larger circle, because we're going back now, which is 6 root 5. So in this case, we can now take this point and translate it to that other position there. And when I do that, we remember that our D is R minus the small r right there. So that means to get to that point, I will just minus the small r, which is 2 root 5, which is the second option that I'm having right here. Or to get to this point, I can say subtract by into, I'm going to now subtract to get this point to get here, into negative 2 root 5 in that case. So that those are the two options that we're getting. So either this point can touch at the end, or this one can touch them. So that's how they're going to touch internally. Then we can now find our K to be how much? K can either be 11,06 units, or K, it is now 28,94 units. So this one is 28,94. And this one, it can be that 11,06 units to get to that point. Now, grade 12, let us now focus our attention to Euclidean geometry. Now, Euclidean geometry, we have 8.1 then. 8.1 is allocated 5 marks. And for this question, you are going to be given 5 minutes to complete this activity. And your 5 minutes start now. Right. Now, grade 12, let us look at the solutions to 8.1. So our 8.1, it says, in the diagram, O is the center of the circle. Use the diagram to prove the theorem that says the angle subtended by the chord at the center of the circle, it is equal to the twice the angle subtended by the same chord at the circumference. So we need to prove that TOP, it is equal to 2TKP. So this is 2 times TKP. Then how do we do it? Remember, when you are proving these theorems, you must start with construction. And when you draw and you show construction, you must also show it on your answer sheet. And you say, construction, draw KO, produced. So we need to work with the two triangles. Remember, when you prove this theorem, we are going to use the exterior angles of a triangle. So we must show that construction with the dotted lines. Thereafter, we are going to work with the construction and say, this is going to be my O1, this is going to be my O2, this is my K1 and my K2. Show that on a diagram so that the marker knows what you were trying to communicate. Now we say that O1, it's equals to K1 plus T. That is why it's an exterior angle of a triangle. As you can see, we have a triangle there, the exterior angle of that triangle. And again, but K1, it is equal to T. Why? Because this is, we have radar here. These two lines are equal right there. Even these ones will be equal in this case. If we can check, we'll have an isosceles triangle on that side. Then therefore, our O1, it can now be equals to 2 times K1, right? Why? Because we can now say O1, it's equals to K1 plus, remember we said K1 equals to T plus K1 again. So O1 is now 2K1. The same thing we're going to do on the second triangle. We are going to say O2, it is equals to K2 plus P, which is the exterior angle of a triangle. The same thing I did on my first triangle, I will also now remember that K2 and P are equal, opposite, angles opposite equal sides. We have an isosceles right there, then we know that the base angles are equal in this case. Therefore, we will remember that O2 is equals to, it's going to be K2 plus, again, P is equals to K2. So I can substitute that, replace the P with K2. Then we know that our O2 is now going to be what? 2 times K2. Thereafter, we can add the 2 to say O1 plus O2, both of them, is equals to the O1. Remember, it was 2 times K1, this was O1, plus O2, it is 2 times K2. Thereafter, I can now take out 2 as a common factor. Then we can see that O1, which is O1 plus O2, which is TOP, it is actually 2 into K1 plus K2. Therefore, K1 plus K2, remember, it's giving me TKP. So TOP is now equals to 2 times TKP. Right, grade 12, let us look at 8.2. And for 8.2 grade 12, you are given 5 minutes to complete 8.2. And your 5 minutes start now. Welcome back, grade 12. Let us look at 8.2. In 8.2, we are told that in the diagram, O is the center of the circle, A, B, C, D, it is a cyclic quad. Okay, we are told that A, B, C, D is a cyclic quad. Even if they did not mention that it is a cyclic quad, we must remember that these are 4 points on a circumference. They're going to give us a cyclic quad. Now, we are told that O1, it is 4x plus 100, and C, it is x plus 34. Calculate the size of x. Before we can find the size of x, we know that C and A, in that case, we know that they're going to add up to 180 because those are the opposite angles of a cyclic quad. Remember, we're given A1, O1, and we're given A. So there are two options. We could have used that and used the opposite angles of a cyclic quad, or we can use the angle at the center. It is twice the angle at the circumference. That means we can say O1 is equal to 2 times angle A in this case. Our O1, it was 4x plus 100. It's equal to 2 times A divided by 2, divided by 2, divided by 2. Then we get 2x plus 50. It's equal to our angle A. So that's how we get our angle A. Thereafter, we are now going to use this and that. When we add them together, those are the opposite angles of a cyclic quad. We know that our angle O or C plus our A is equals to 180. So we have established that these are equals to 180 when we have started with that. So then we can now solve for x. Then we can find that our 3x equals to 96. Then our x equals to 32. Now grade 12, we have 8.3 again. Now 8.3, we have 8.3.1 and 8.3.2. And for these two questions, you are going to be given 5 minutes to complete the two activities. And your 5 minutes starts now. Welcome back, grade 12. Let us look at 8.3. On 8.3, we are told that in the diagram, O is the center of the circle. So O is the center of the circle. OP, it is the diagram is a diameter of the smaller circle. I think it's supposed to say diameter there, because you can see OB is a diameter, and chord AB of the larger circle intersect the smaller circle 8B. So we have a chord AB right there. Write down the size of OMB. They want to know how much is that size. That size is going to be 90. Why? Because that is an angle subtended by diameter OB. So we can say OMB equals to be 90 because it is an angle in a semicircle by the diameter OB. Right. Let us move on. Remember, this is 19 using that diameter. They tell us if AB is root 300. So AB is the root of 300. And we are also told that OM is 5 units. So OM, it is 5 units. They said calculate the length of OB. How would you find OB in this case? We now know that, remember, our AB is root of 300 and our MB, it is equal to half of this. So it's divided by 2. Why? The line from the center perpendicular to the chord. So the line is was drawn from the center perpendicular to the chord. That means these two sides are equal. So that means the 10 root 3 divided by 2, it gives us the MB. So our NB is 5 root 3. Then what we see then? We see that OMB, it becomes a right angle triangle. To work around OMB, we are now going to say OB squared is equal to OM plus MB, which is Pythagoras, because this is a right angle triangle. So OMB, it is the right angle triangle. Then I can substitute in my values. Then OM is 5 squared. Then MB, it is 5 root 3 all squared. Then our OB, it is 10 units. All right. Now, grade 12, let us look at question 9. Now, for this question 9, we are going to be given 10 minutes to complete from 9.1 until 9.3. And your 10 minutes starts now. Welcome back, grade 12. Let us now discuss question 9. Now, on my question 9, we are told that in the diagram ABCD, it is a parallelogram. Okay, so we have a parallelogram with AB, which is 14 units. So this is 14 units. And AD is produced to E. So AD is produced to E. That AD is to DE, it's 4 is to 3. So we can now see that AD is going to be 4. So I need to attach a letter when I now translate my ratio into my diagram. Remember, now we're working with the ratios and proportionality. So this is going to be 4p, then DE is going to be 3p. Very important right there. Now, and we're told that EB intersect DC. EB, it intersects with DC. As we can see, they intersect at F. Now, our EB, it was given as, so the whole of EB, it was given as 21. Now, the question says, determine the length of FB. They want us to find FB. Now, what do you see here? We can see two shapes here. We can see that we're looking for FB. So the shape we took is that one, and we take the same shape that way. So we are going to do the same thing on my left-hand side. We know that this is going to be that, and the larger one. Why am I taking the larger one? Because we are given the size of the larger one. And remember, 4 plus 3, this is going to be 7p. So how am I going to work with proportionality here? We are told that DC is parallel to AB. So the two sides are in proportion. So the first thing I'm going to do, I am going to work and say FB all over EB. So FB over EB, which is this side, it's equals to DA all over A or EA, which is the longer side right there. So it is proportionality theorem, because we know that DC is parallel to AB. Thereafter, how do we now work around and get to that point? Let us now proceed. We know that our FB all over EP, it's going to be what? It's now equals to our DA, it is 4P, so it's 4P all over my EA, it is 7P. I am looking for FB. What can I do? I can multiply by EB. I can multiply by EB. Then my FB, it's equals to 4P over 7P multiplied by EB. My EB, it was given as 21. Multiplied by 21 in that case. Thereafter, the P and the P will cancel out. Then 4 over 7 times 21, it gives me 12 units. Let's look at 9.2. Prove with reasons that triangle EDF is similar to triangle EAB. To prove the similar triangle, we are going to use angle, angle, angle. Now, which triangles am I working with? It's EDF, so it's EDF. Right. For this one, we're going to use multiple colors so that we are able to work with it. And our larger triangle, it is now EAB. Right. So we're going to look at our large triangle, which is EAB. So it is advisable that we can use two different colors so that we can see which triangle we are working with, or we can even throw them outside. Now, the first thing that we see in both triangles, E is common. So E is found in the big triangle and the small triangle. You can see there's both colors there. Thereafter, I can see that the two lines are parallel. Then this angle and that angle must be equal using the corresponding angles. So EDF, it is also equals to EAB. So that is this and that as that. So these two are giving us the corresponding angles, not this ones. So those two are giving us the corresponding angles. However, therefore, we can now say EFD is now equals to EBA. Why? That is a third angle of a triangle. It's a third side of a triangle. Therefore, we can now say EDF, it is now similar to EAB. Calculate with reasons the length of FC. How are we going to find FC in this case? Now, how would you find FC? To find FC, we are going to work with the congruent triangle or the similar triangles that were given to us, right? So I'm going to find that congruent triangles as they are in this case. So it is EDF and EAB. So EDF and EAB. EDF and EAB. Now, how do we now work with congruency here? Let's continue to proceed. EDF and EAB. So let's proceed in this case. So we have that from the previous similarity then. When we have the similarity, how do we work around similarity in this case? What is the first thing that we are supposed to do? We are now supposed to check and say, okay, I'm going to work with my smile face. I am going to say this eyebrow and a smile. That is how I work around this one. So even here, I'm going to say eyebrow, and a smile. So meaning I'm going to say ED, which is the ED right there, all over EA is equals to DF over AB. So it is eyebrow. It's equals to, again, EF. Remember, We are using this from similarity, and you must follow the same order. EF all over EB. EB. When we are here, we are now going to do what? We are going to discard some situations here so that we are remaining with what we are looking for. So in this case, what are we going to work around? We are going to work around DF over AB. It's equals to ED over EA. So those are the 2 points that I'm going to work with. Why? Because we are given more information on them. We are given the length of AB that I'm going to work with, and we are also given the length of EB that I am going to work with. Right. Then from here, how are we going to find my DF? How do we find DF? We know that ED over EA. You must remember this was 4P, this was 3P, the whole of this was 7P. Now, if we can check my ED is going to be 3P, so DF over AB, it's equals to ED, it was 3P, all over EA, which was 7P. Right, so that's what we get in this case. And remember, we are looking for the DF first. To find our DF, because if we can find our DF, we'll be able to find FC. To find our DF, we are going to now say multiply by AB over 1, multiply by AB over 1. Then when I do that, I find my DF is equals to 3P over 7P multiplied by 14. Then my DF is going to be how much? It's going to be 6 units. After finding my DF at 6 units, remember, we are told that AB, it is also 14 in this case. Now, how do we now find FC? Then we know that our FC is going to be 6 minus 14. It's going to be 8 because both sides must be equal as we're having a parallelogram. Now, grade 12, let us look at question 10. So from 10.1 to 10.3, you are going to be given 15 minutes to complete those 3 questions. And I believe that these are going to be our last questions for the day. So those 3 questions, your 15 minutes start now. Welcome back, grade 12. Let us look at question 10. We are told that in the diagram, PQRS, it is a cyclic quad. So PQ, okay, I think let's just go to the first solution. So it's PQRS, it is the cyclic quad. And we are told that such that my PQ is equals to PR. So PQ is equals to PR. Now, remember, if we go through our pre-analysis already, we can now see that these two are equal. So we must also establish that PQR is equals to R3. PQR is equals to R3. Why? Angles opposite, equal sides. We already can establish that without proceeding. Again, the tangents to the circle at P, we have tangents to the circle at P and R, they meet QS and are produced at A. So they are produced at A in this case. So they meet the QS produced at A. So those are the 2 tangents from the same point that we are going to work with. Then RS is produced to meet tangent AP at B, and we are also told that PS is produced to meet tangent AR at C. So those are the points that are produced. Then PR and QS intersect at M. Prove with reasons that S3 is equals to S4. How do you prove that S3 equals to S4? The first thing that we're going to do here, we are going to work with the information that was given to us. We are going to check S3 and S4. If you can see my S3, it is outside of the cyclic quad. and S4 is inside of the cyclic quad. So I am going to work around that cyclic quad to find those two values. I can see that my S3, it must be equal to PQR. Why? That's an exterior angle of a cyclic quad. So we know that S3 is equal to PQR is an exterior angle of a cyclic quad. So I'm going to mark them with X and X so that I can see those two are equal. Then what else do I see from my equations here? I already established that these two are also equal. Remember, we said PQR is equal to R3. Remember, grade 12, we can also assign letters so that we can be able to easily work with this question. We told that RL3 is equal to PQR, opposite angles opposite equal sides, which is what we worked with around there. So those two are also equal. So I can call that X and X. Now, as I proceed, what do I see? I see that I can now see that therefore, because both of them are equal to PQR, then S3 is now equals to R3. So both of these are now equal. So if those two are equal, I see there's a charge here. Now, from that chart, what are we going to have? We are now going to have, but S4, it's going to be equal to the R3. So we have a butterfly. So those two are equal. So these are the angles in the same segment. Then therefore, both of them are equal. Therefore, then S3 is now equals to S4 because they're both equals to R3. 10.2, we need to prove that S M R C, it is now a cyclic quad. How do you prove a cyclic quad? We can prove it by the exterior angle of a cyclic quad equals to the opposite interior angle, or we can prove it with the angles in the same segment. Now, how are we going to do this? We know that ARP, because if I can draw the triangle then, it is equal to PQR. That is my tan chord theorem. Again, and we have proven that S4, it is also equals to PQR. It's proven in 10.1. What can I see now? I can see now these two are equal. If I say this X, this is X, and that is going to be X. Because those two are equal and that are equal again. So remember the importance of using letters. I can say an exterior angle of a cyclic quad already. Then I can now say my S4, it is equal to ARP. Why? That is an exterior angle of a cyclic quad. So we can say SMRC, it's now because these two are equal. As you can see, they're both equal to X according to our sketch. Then it is a cyclic quad, which is the converse of the exterior angle of a cyclic quad. So if these two are equal, therefore SMRC it's equals to, it's a cyclic quad. Now let's look at 10.3. So for 10.3, we are told prove that RP is a tangent to the circle passing through. So RP, so what is my RP? RP, it is a tangent to the circle passing through P, S, and A. So we have a circle here. They said on this circle, prove that we have a tangent. To prove that we have a tangent, we just need to prove that this angle is equals to that angle. Now, what can we do to find that those two angles are equal? We are going to say our S3 is equals to R2 and our P2. That is an exterior angle of a triangle in this case. And also S4 it's equals to my P1 and P2. So let's show the two triangles using different colors. The first triangle that we're working with, so work around the two triangles. And our second triangle, we can now find it to be, this is our exterior angle of that triangle. Then proceeding, our second triangle, we're going to look at this triangle. Remember, I want to prove that these are tan chord, right? So we're going to work with that. So we have two exterior angles of a triangle. However, then we can now equate them together and say R2 is equals to R2 plus P2 is equals to P1 plus A2Y. This is S3, it's equals to S4. Remember, this was proven above. Because the two are equal, now let us solve the equation in this case. Therefore, we can now see that our P1 is now equals to R2 in this case. So we can now see that P1 equals to R2. So that's why we can now conclude that we have a tangent passing at that triangle. So P1 is now equals to that value right there. Then therefore P2 again, it is equals to A2. So P2 is equals to A2 in that case. Therefore, we can now say RP is the tangent to the circle because we have a converse of a tan chord theorem. So that is our tan chord theorem then, and we can now say we have the converse of that tan chord theorem. And now that is how we can prove that a certain line, it became what? It became a tangent to a circle at that point. Now, grade 12, that brings us to the end of our lesson. Enjoy the rest of the day, and I hope this revision is going to help us navigate through the revision on paper 2. Thank you. Enjoy the rest of the day.